Hey everyone, so today we're going to tackle a question that is absolutely critical for anyone working with data. You spent all this time building a forecasting model, but how on earth do you know if it's any good? Let's dive in and figure that out. Okay, so you've put in all the hard work. You built your time series model, maybe it's an ARIMA, maybe something else, and boom, you've got a forecast. But here's the million-dollar question. Is it actually any good? How do you know if your prediction is on the money or if it's just, a lucky guess? Well, to get a real answer to that question, you need the right set of tools. And in the world of data science, we call these tools performance evaluation metrics. Think of them as the secret sauce for really understanding and then improving your forecasts. And this really gets right to the heart of the matter. Just building a model isn't the finish line, not even close. We have to measure its performance. We've got to put a number on its accuracy before we can ever trust it to help us make real-world decisions. So why do we bother with all this? Well, for one, it's how we measure accuracy. It's also how we can compare a few different models side by side to see which one is the champ. And maybe most importantly, it helps us understand the kind of mistakes our model is making. Once you know that, you're on your way to making way better decisions with your data. All right, enough talk. Let's get our hands dirty with the tools themselves. We're going to start with two of the most common metrics you'll ever see, MAE and RMSE. Both of them are all about one thing: measuring the absolute size of your model's mistakes. First up is MAE, which stands for mean absolute error. And honestly, this one is super intuitive. All it does is look at the difference between what you predicted and what actually happened. It strips away the plus or minus sign, and then it just averages them all up. Just think of it as your model's average mistake size. It's simple, it's clean, and every single error is treated equally. But hang on a second. What happens when not all mistakes are created equal? What if a bunch of little errors are totally fine, but just one single gigantic error could be an absolute disaster for your project? Well, that's where MAE might let you down. And that brings us to our next tool, RMSE, or root mean square error. Now, the keyword here is square. Before it does any averaging, RMSE squares each error. And what does that do? Well, it makes the big errors huge. It gives them way more weight. So this metric is specifically designed to punish those big, costly mistakes. I love how this slide frames the two. Think of MAE as a Democrat. Every error gets one vote, big or small. RMSE, on the other hand, is like a strict judge. It comes down hard on the major offenses. So if your top priority is to avoid those big outlier mistakes, RMSE is definitely going to be your friend. Okay, so measuring the absolute size of the error is one way to go, but it's not the only game in town. Our next couple of metrics, MAPE and MASE, they shift the whole focus to relative error. And trust me, this gives us a totally different and often much more useful perspective. Let's talk about MAP. That's mean absolute percentage error. And its superpower is that it's just so easy to explain to anyone. It tells you your error as a percentage. So instead of saying your forecast was off by $500, you can say it was off by 10%. That makes it fantastic for comparing forecasts across things with totally different scales. But MAPE has an Achilles heel. It has this one huge weakness that we call the zero problem. See, if the real value you were trying to predict turns out to be zero, you end up trying to divide by zero in the formula, and the whole thing just breaks. This can be a real headache in situations like demand forecasting, where zero sales happen all the time. And that leads us to our final and maybe most clever metric, MASE, or mean absolute scaled error. MASE is brilliant. It dodges that zero problem completely, and it answers a really practical question. Is my fancy model actually any smarter than just a super basic guess? It does this by comparing your model's error to the error from a simple, naive forecast, like just guessing that tomorrow will be the same as today. And the best part? The takeaway is so simple. It's this one rule of thumb. If your MASE score comes in at less than 1, pop the champagne. Your model is officially better than a simple baseline. If it's more than 1, well, that means you might be overthinking things. It's an amazing reality check. Okay, theory's cool and all, but let's make this real. Let's see how all these different metrics actually behave out in the wild. We'll use a classic sales forecasting example to see how each tool gives us a slightly different piece of the story. Now, before we get to the example, take a look at this. This is your ultimate cheat sheet. It lays out the core idea, what each metric is best for, and what to watch out for, all in one spot. MSE is your average mistake, RMSE punishes the big ones, MAPE gives you that nice percentage, and MASE tells you if you're beating the baseline. So picture this.
You forecasted your weekly sales for the past month. Now the real numbers are in, and it's time to see how you did. We're going to take the exact same set of predictions and actuals and run them through all 4 of our metrics.
So we run the numbers, and first up, our MAE comes out to $55. What does that mean? It's our average mistake size. It tells us that on any given week, our forecast was off by about $55, either too high or too low. A really simple, straightforward starting point.
But then, whoa, look at this. The RMSE is way higher at $92. Remember, our MAE was only 55. This is a huge red flag. It's our strict judge telling us that even though the average error was okay, there must have been at least 1 week where our forecast was massively wrong.
Next, we calculate MAPE, and we get 12%. Now, this is the number you can take to your boss or put in a presentation. It translates everything into a simple percentage. On average, our weekly forecast was off by about 12%. Easy to understand, right? And finally, the moment of truth. Our MAS score is 0.8. And what was the rule? Anything under 1 is a win. This is fantastic news. It tells us our model isn't just spitting out random numbers. It's providing real, actual value. In fact, it's performing a full 20% better than a basic, naive guess would have. That is a solid result.
Whew. Okay, we have covered a ton of ground. So what's the big takeaway here? And maybe more importantly, how in the world are you supposed to remember all of this when you actually need it?
Don't worry, I've got a super simple memory trick for you. Just remember the letters A, S, P, C. A is for the average error, and that's our MAE. S is for the squared error, which is our strict judge, RMSE. P is for percentage error, that's MAPE. And C is for the comparison metric, our reality check, MASE. ASPC. You'll never forget them now. And so we end right where we started. Which of these metrics is actually the best one? Well, the truth is, there is no single best metric. The right tool for the job is always the one that best answers the specific question your project is asking. Are you just trying to get a feel for the average error, or do you need to avoid huge mistakes at all costs? Do you need to communicate in percentages, or just prove your model is worth it? The question you ask determines the tool you should use.